Okay, so for this Lewis structure video, we're going to start looking at atoms that have expanded octets. So XEF2 is an example of this, and we're still going to follow basically the same rules that we did for the other Lewis structures that we were doing in earlier problems. It's just now we're going to have to figure out where we're going to put these extra electrons. So first thing we're going to do is figure out the number of valence electrons. So xenon has 8 as a noble gas. You have 2 fluorines, each of which has 7, so that's 14. So we have a total of 22 valence electrons available that we need to place. Next thing we're going to do is put the atoms in single bonds. So I'm going to call Xc my central atom. I'm going to put a fluorine and put a fluorine on the other side. Okay, so that's step 1, that's step 2. Now we got to complete the octets. Okay, start around the periphery here. That fluorine now has an octet. 4, 6. Okay, this fluorine now has an octet, and now we got to place the remaining electrons in the central atom. Okay, so here's where if we come up short, we've been adding a double bond. If we come up right to an octet, we've been good. We have 6 electrons left. We put them all in place, and now we look and we have an octet on this fluorine, an octet on this fluorine, but on this xenon molecule right now we have 2, 4, 6, and then 8, 10. We have 10 electrons. Okay, but however, since xenon is in the third period, it is able, or sorry, below the third period, okay, xenon is able to carry more than an octet. It can take an expanded octet. Okay, the fluorines can't since they're in the second period, but anything in the third period or below, okay, so things like phosphorus, sulfur, chlorine, argon, krypton, xenon, iodine, bromine, these can all take an expanded octet. And so if we have leftover electrons, and that's where you need to put them, there we go. Okay, this will give you just to give you a quick hint as to how you deal with these things. In general, when you see that you have more electrons than you need for octets, you're going to put extra electrons on the central atom, generally. And it has to be something that's in the third period or below. If you have too few electrons, you can't complete an octet, and it's not one of the exceptions such as boron or beryllium, then what you need to do is start to make double bonds to get up to an octet. Okay, so you shouldn't be drawing double bonds if you have more than an octet of electrons on a central atom, for the most part. Okay, there are certain cases that you might learn about in AP chemistry where that will be the case, and we'll talk about it a little bit in the next example, but in general, you're going to, if you have more than an octet's worth, you'll put them as lone pairs on the central atom. If you have less than octet's worth at the end, then you need to start making double and triple bonds to bring it up to an octet. Okay, so now let's take a look at another molecule. In this case, we're going to look at the phosphate molecule, the phosphate ion, polyatomic ion, PO43-. Just like all of these, first thing we need to do is figure out valence electrons. So we have 5 for phosphate. There are 4 oxygens, each of which has 6. That's 24 there. And since it's 3-, we must have 3 extra electrons. Okay, so this is going to total up to 32 valence electrons. So that's how many electrons we need to place. Okay, the next thing is we need to place atoms and single bonds. We know we have phosphorus in this case, PO43-, probably going to call that the central atom. We're going to put an O, O, and an O. Okay, I'm going to change colors here for the electrons, make it easier to look at. Alright, so we're going to complete our octets around the oxygens here. Alright, so we've got our octets, and if we count up the electrons right now, we're at 32, and we should be at 32, so that's all good. And now the other thing we need to do is, because this has a charge, we need to make sure to signify that with a 3- around it to show that this is PO4 3-, not just PO4. Alright, so really quickly going to just shrink this down, move it to the side a little bit, and I'm going to draw this again as well, but with a slightly different structure. Okay, and what we're going to do is we're going to draw it in this way. Okay, and the reason for this is, remember in the last thing we were talking about expanded octets, and the fact that elements that are down in the third period or below can have more than an octet. Phosphate happens to meet those criteria, so that's one of them. And if you take a look at this right now, we have another structure that has 32 electrons as well. We have an octet on the oxygen, an octet on this one, an octet, an octet. Here we have 10 around the phosphate. Now, around the phosphorus, sorry. And it just turns out that this is the way that this is actually typically going to be drawn. So the reason we wanted to just bring this up here, this is beyond the scope of this course, has to do with formal charge, but here's an example of something that you might learn in your advanced placement chemistry class, should you continue to take chemistry. And so just wanted to bring that up. You will see it. We will accept both of them as plausible. That doesn't mean you should go around necessarily looking to add a double bond every time. Remember in the previous solution I said for XEF2, anytime you're sort of under an octet, you need to look to make a double bond. Anytime you're over, you're generally going to put down lone pairs. But if you do see this in a book or other videos or something somewhere, just sort of be aware that there are cases where you can give something an expanded octet, like the phosphorus here, and that's actually okay, and in some cases that's the way that it's typically shown. There's resonance structures as well, which we'll talk about in the next section here, which is the double bond could really be drawn on any of those oxygens, and in reality will probably be on any one of them 1/4 of the time. Okay, but just want to give you an idea for phosphate and how you would deal with that situation should you see the double bond.